Metal cans, glass jars, as well as plastic and PET bottles are widely used in the food and beverage industries to package a variety of products for dairy, cereals and grains, condiments or sauces, confectionery items, fish, seafood, fruits and vegetables, infant foods, meat, and even snacks. This webinar looks at the ability of Xray technology to enhance the safety and quality for both food and beverages packaged in tall rigid containers and processed at high line speeds. For simplification, we have subdivided tall rigid containers into three categories based on the density of the packaging used. First is cartons, plastic bottles, and composite cans. Second are metal cans. And third are glass containers. This webinar explores the challenges each packaging material presents, looks at the various Xray systems available, and how they can be applied to ensure optimal results. Xray systems help to ensure food and beverages are safe to consume by detecting physical contaminants such as glass shards, metal fragments, mineral stone, calcified bone, and some plastic and rubber compounds. In addition, modern Xray systems are multitasking defenders of product and brand quality. In a single pass and at high line speeds, Xray systems can help manufacturers increase productivity, save costs, and minimize product waste by simultaneously measuring mass, counting components, checking fill levels, and detecting damaged containers and product trapped within seals. Xray systems fall into two categories: vertical beam and horizontal beam. Vertical beam Xray systems are commonly used to inspect products which are smaller in depth than they are in width and length. In contrast, horizontal beam Xray systems are primarily used to inspect products in packs, where the height of the pack is greater than its width. Since a key factor in detection sensitivity is the depth of product through which the X-rays must pass, a horizontal scan usually results in better detection rates for these kinds of packs, which means that the X-ray generator is mounted on the side of the machine cabinet and scans through the side of the container. A side shot image allows easy application of dynamic software filters to the densest areas of the image, which is usually the perimeter of the packaging. This optimizes detection levels and minimizes false rejects. Dynamic software filters are particularly important when inspecting metal cans or glass and ceramic containers. Manufacturers across the globe are increasingly integrating Xray inspection equipment into their production lines. The end goal is to protect the well-being of consumers and reduce the risk of product recalls. However, different applications require different solutions, and selecting the right Xray system to suit a specific product and packaging type is essential to ensure optimal sensitivity and minimal false rejects. Let's first explore low-density packaging, such as cartons, plastic bottles, and composite cans. Cartons, PET bottles, plastic jars, and composite cans in tubes are used to package infant formula, cereals, condiments, confectionery products, snacks, pet food, and much more. Such packaging presents few challenges to Xray inspection, as the container material absorbs low amounts of Xray energy. An Xray system with a single horizontal beam is best suited to detect physical contaminants and quality defects in products packaged in low-density packaging. A single horizontal beam Xray system has one Xray generator, which creates an Xray beam that skims across the surface of the conveyor belt. The system scans containers as they pass through a single detector set and, since the beam must be wide enough to encompass the tallest container, a variety of sizes of beam geometry is available. In addition to detecting contaminants in cartons, plastic bottles, and composite cans, Xray systems are simultaneously capable of verifying fill levels, counting components, and detecting product trapped within seals. Let's now turn our attention to metal cans, which are used to package beverages, dairy products, fish and seafood, fruit and vegetables, infant feeding products, including milk formula, meat, soups, ready meals, and pet food. Metal cans are more challenging to inspect than cartons because the packaging is denser. In addition, metal cans usually contain high-density product, and, if the can diameter is large, they put more product in the path of the beam. However, the toughest challenge when inspecting metal cans is detecting small contaminants that are located on the base or the side walls of the can, especially if the can has sidewall ribbing. Ring pulls can also affect sensitivity, and the best results are achieved when the ring pull is located on the base of the can. A dual-view X-ray system is best for inspecting metal cans. From a single X-ray generator, X-ray radiation is funneled through a dual diverging collimator, creating two beams that are angled away from each other. The beams strike two separate detectors so that every can is imaged twice. Each image represents a different viewing angle, thus increasing the coverage inside the container and the probability of detection. Contaminants located on the side wall in one image appear nearer the center of the pack in the other image, which makes them easier to detect. In addition to detecting contaminants, X-ray systems with dual-view technology are simultaneously capable of measuring mass, monitoring fill levels with filler feedback, and checking for container defects, such as dented cans. Finally, let's look at glass jars and bottles, which are used to package a wide variety of applications, including beverages, condiments, confectionery, fish and seafood, fruit and vegetables, infant feeding products, sauces and soups. Despite its popularity, glass packaging poses a significant safety risk, and the effects of glass-in-glass contamination can be highly damaging. Glass containers are notoriously one of the most challenging types of packaging to inspect. This is mainly because the primary contaminant is glass, which is the same material and density as the packaging. In addition, the base, sidewalls, and necks of glass jars can all cause an area with limited detectability. For a detailed explanation of factors affecting detection sensitivity in glass containers, please visit the Knowledge Center on eaglepi.com. A single beam X-ray system provides an acceptable level of detection in the body of glass jars, but not in the base or at the top of the container. The base crown is perhaps the biggest challenge, since this can vary greatly. Plus, it's the densest part of the jar. Contaminants lying in the base channel around the crown can go undetected if they are in front or behind the crown. These contaminants will be hidden in the dark shadow of the crown, which will probably have been filtered out already. The probability of detection can be improved using a dual beam X-ray system, which has a generator that creates two separate angled X-ray beams directed towards two detectors. They create images showing the view through the jar from two different angles, which means a larger area of the base or crown is inspected. It's also easier to spot contaminants located on the side wall because they appear to be nearer the center in one of the images. However, dual beams can't always offer 100% inspection of glass jars. For this reason, X-ray systems are now available featuring multiple beams. An X-ray system featuring a combination of horizontal and angled beams is the next step for increasing coverage and optimizing detection in more difficult areas, such as the base, sidewalls, and necks of glass jars. These three images compare the coverage at the bottom of the container offered by single, dual beam, and combination beam X-ray systems. In addition to offering unrivaled contaminant detection, X-ray systems with 4-view detection coverage are simultaneously capable of measuring mass, counting components, and monitoring fill levels. As well as helping manufacturers avoid waste, the ability to detect underfills and overfills can be beneficial when filling liquids, such as sauces or jars of vegetables, which rely on a specific amount of liquid within the container to preserve the product. By ensuring the highest safety and consistent quality of a wide range of products packaged in tall, rigid containers,
Xray Systems can reduce the risk of recalls, safeguard brand reputations, and protect the well-being of consumers. In addition, investing in Xray technology can help manufacturers comply with HACCP-based Global Food Safety Initiative recognized standards. However, as this webinar shows, Xray inspection is a versatile technology, and different products and packaging types require different solutions. Selecting the right Xray system to suit a specific application is crucial to guarantee maximum detection sensitivity in high throughputs.
Visit eaglepi.com for detailed information on Eagle's advanced Xray technologies for rigid containers. Thank you. And if you'd like to stay up to date with the latest product inspection trends, just follow us on social media. Connect with us on LinkedIn. Follow us on Facebook at Eagle Products Inspection. Follow us on Twitter at Eagle Xray. Follow us on Google+, and subscribe to our YouTube channel.